we're going to do our first simplex problem. Now, this is a standard simplex problem, so it's the easiest of all of the above. And let's go through the steps slowly and make sure we understand what's going on. So now, the first thing we're going to do is write the objective equation, or the function, so it is equal to 0 and p is positive, meaning the coefficient on p can't be a negative number, so it has to be a positive p instead of a negative p. Now, what that means is we're going to take our function and just essentially just subtract everything else to the other side and get everything over to p. So does that make sense? I just subtracted the 2x and I subtracted the y and moved them over to the other side, and there we go. That's it. That's step one. It's equal to 0. P is a plus sign in front of it, not a minus sign. That's your objective function. Okay, step two. Step two. Now, step two here is saying rewrite all the constraints, so those are all the less than or equal to's, with equal signs using slack variables. Okay, now, here we go. So our first constraint, we are going to rewrite it so they're equal to instead of less than or equal to. Now, what that means, you might be saying, okay, that seems right, so now it's an equal to. But that's not really fair. You can't say it's just equal to. No. So what we're going to do is we're going to make up crazy random variables that didn't exist before. So I'm going to say plus q, because there was no variable q in my system. Now, you might be saying, why plus? Well, because I know this stuff was less than 6, if I want to make it equal to 6, then I would have to add something. Because if I subtracted something, then it would make it even more smaller, more or less than 6. So if I want to make it equal 6, then I have to add something. And remember, this is hinging upon the fact that all of our variables have to be positive. X has to be positive, Y has to be positive, P has to be positive, and any variable I make up has to be positive. You don't need to notate that you don't have to add all these into your constraints, but it's just something we need to be aware of. So there's our first one. Okay, so on to our next equation. We're going to make this one into an equals to as well. And I need to add, because it's less than, so I have to make the stuff on the left bigger so it equals 8. But I can't say q, because if I say q, then what I'm saying is however much this was under 8 by, this was also the same amount under in 6. I don't know that. I don't know how much less it was. So here comes another new variable, r. So that's why they're called slack variables. We just make them up out of thin air, and there you go. So now we have created, whoops, there we go, step 2. We have rewritten all of our constraint functions with equal signs, and we have created slack variables for each equation. So yes, you are going to have one slack variable per constraint. So if I had, instead of having 2 constraints here with line A and B, if I had 17 constraints, then I would have 17 slack variables. And you just have to get creative because you'd run out of letters in the alphabet. Good news, we're not going to do that in here, but you could if you wanted to. Next, we're going to write the equations in a matrix with the objective function at the bottom. So essentially, the whole point of this was getting everything into kind of a standard form. So just for our general matrices, how we've set them up to this point, we had always had, the x's in the first column, y's in the second column, and now we're going to have some extra variables, but that's okay. That doesn't bother us. So we're going to have then q, then r, then p. Now that takes care of all of our different variables, and then an equal sign. You may be wondering why I set them up this way. You'll see in just a second. Now, the objective function has to go at the bottom, so I'm going to start with the constraints. This is going to be my first line. This is going to be my second line. It doesn't matter which one goes where. They're arbitrary. But the objective function has to go at the bottom. No matter how many equations you have, this one has to go at the bottom. So -1, 1, 1, 0, 0, 6. The next line would be 2 x's. This is supposed to be a y, not an x. There we go. -1, 0, 1, 0, 8. And then for our objective function, I always denote it with a little line showing me that this is my special function, so now I have a -2, -1, 0, 0, 1, 0. Now, you'll notice the reason I do them in this order, where I do my the P at the end is because I get a nice little identity matrix right in here if you look at it. And it helps you visually recognize if you got everything you needed to. All of your slacks and your P should always look like a little identity. Okay, now I'm going to put the augmented bar here just to show this is my equal signs. And now we're done. We're set up as a matrix. Okay, so here we go. On to the multi-step part. Now, this is when it says multi-step. What I mean is we're actually going to just do this over and over and over again until we get an answer. And we don't know what an answer looks like yet, so don't worry about that. But right now, we're just going to work on the steps. So what we're going to say here is locate the largest negative number in the objective equation to determine the column for the pivot. So we'll explain what's going on here in just a second, but the idea is find the largest negative number down here. The largest negative number, oh, that's -2, which means I am going to pivot in the X column. This is the column in which I'm going to pivot. So when I say pivot, what I mean is we're going to draw a box around it and then use this number to get zeros above and below, just like we used to do in reduced echelon form. Except now we're not going to follow a pattern where we're always going to start in the top left-hand number and work our way diagonally. Now we go through this process and we're going to do our row operators just from random places throughout the matrix. So I know I'm going to pivot in the X column because it had the largest negative number. Okay, now let's look at what the next part of this rationale is. Use the ratio of the equal sign column with the number in the variable column determined in part A to find which is the smallest ratio. What on earth? Okay, so all we're going to do is take the equal sign number and the column we just determined. I said the X column is where my pivot's going to be. So I'm going to do 6 divided by -1, or the way I'd rather write it is 6 divided by -1, which makes -6. This one would be 8 divided by 2, which would be 4. And we will never pivot in the objective equation. We're always pivoting in the constraints. So therefore, my pivot will be the smallest. What we're looking for is the smallest positive ratio. Okay, so out of these, my ratio was 4, was the smallest positive number, so my pivot will be right here on 2. Okay, now I am done with these numbers. So you could have just done that in your head, or you could do that on side, or you can erase it just like I did. We're done with them, we don't need them. This is my pivot. So now my row operators. I'm going to use row operators with this row. I'm going to use row 2 to eliminate the values above and below to turn them into zeros. So what would that be? Okay, I need to take row 2 plus 2 row 1s to make a new row 1. And I'm going to need to just do row 2 plus row 3 to make a new row 3. Now the rule is if my pivot's on row 2, each of these calculations has to use row 2. I can't use row 2 and row 3 to make a new row 1, nor could I use row 1 and row 3 to make a new row 3. I have to use row 2 in every calculation. So it kind of boils down to, if I'm trying to get a 0 in row 3, then I have to use row 2 and row 3. If I'm trying to get a 0 in row 1, then I have to use row 2 and row 1. This is now going to be very tedious, just a lot of adding and subtracting and going through operators. So this brings up a fun little website that I want to show you. Now, the link to this website was located right here. So this is your link to this website. And this is going to just help us speed through the adding and subtracting. I'm not going to make a big deal about it. I'm not going to ask you to add or subtract on tests. I'm going to just ask you to set up your matrix. I'm going to ask you to tell me where the correct pivot is. I'm going to ask you to tell me what the row operators are, but I'm not going to make you sit there and add and subtract number after number after number. So here's the idea. On this website, up here at the top is where you can fill in your variables. So for us, it was X, Y, and then I forgot what we called it. Do we call it R and P? QRP. Q, R, P, and equal sign. So this is just to help you get your matrix so it looks right. Okay, so then let me do this, see if I can get it all on the screen at once. So now I'm just going to fill in my numbers into this matrix. So -1, whoops, and I'm going to hit tab to move across. 1, tab, 1, 0, 0, and then over here was 6. And now I can't tab because there's too many rows and columns here. So I'm going to click down here and rinse and repeat. 2, -1, 0, 1, 0. And I think you're getting the idea. My only concern is that a student may, here we go, it's 8. A student may say, well, now how do I put the augmented bar in here? Well, you don't. You don't. It's just for our notation. The computer doesn't care. It's just going to do our row operators for us in a nice way. Okay, so there's a 0. Okay, so now I have my matrix typed in. Now, for settings on this site, highly recommend. If you were doing it by hand the way we did it, we want all of our numbers as integers. I wasn't concerned about getting a 1, dividing through to get a 1 off of my pivot. I used the number 2. See, 2 was being boxed. So really all we're going to do is just say, give me integers. Now, what we're going to do in this is saying this was the cell where I was pivoting. So I'm just going to highlight that cell. I'm going to click in it. Now, do you see here it says pivot on selection? So when I click there, boop, it just did the row operators for me. That's exactly what we would have done. So that's what it did. So now I have my new matrix, whoops, that I can copy down. Let me get this to go full screen again. I want it to go, let me do this. There we go. So we're going to now copy our new matrix that it just spit out for us right here. So I have, what do I have? I have 0, 2, 0, 1, -1, -2. Let's see, 2, 0, 0, 1, 1, 1. And then, whoops, go away, keyboard. Let's see, that was R. So P is 0, 0, 1. And then last but not least, we're looking at 28, 8. Okay, and sorry, I'm not working on my normal device. My normal device is in the shop, so things are a little awkward, but I need to make you your videos. There we go. Okay, so now we have our new matrix. And I apologize, I've been neglecting the steps, but what I just walked you through are exactly what the steps say to do. So we use the ratio to determine the smallest ratio, right? The smallest positive ratio. Then pivot on the number that we just found. So that's when we boxed the number 2 and found the numbers above and below. Now we repeat. So if there are still negative numbers in our objective equation, if there's still negative numbers, do it again. Locate the largest negative number. Okay, so we're going to go back here, just like we did on the first step, where we said, okay, step 1, find the largest negative number. Then find the ratio in that column. Then box the number that has the smallest positive ratio. Okay, then pivot off of that. Get zeros above and below. Okay, now rinse and repeat. Do we have any negative numbers? Yes, we do. We still have a -2. So what we're going to do is do the ratio of the y column. So now we're in the y column. So 20 divided by 1. 20 divided by 1 equals 20. 8 divided by -1. And some of you who are picking up on this faster are saying that's a negative ratio. I don't want that. Negative ratios can't work. And so therefore, my only option is pivot there. I have to pivot there. Now, good news, folks. This matrix is already typed into that website. So what I can do is bring that website back up. And I say my new pivot is where? Row 1, column 2. In the Y column, right there. So I'm going to click on that cell. I'm going to hit pivot on there. And now we have our new matrix once again. So rinse and repeat. Write down your new matrix. All right, so here we go. First column 0, 1, 0. Next column 1, 0, 0. Next column 2, 1, 4. The R column is 1, 1, 3. The P column is 0, 0, 1. And I need to scroll over just a little bit. Here we go. So now we're going to end up with 20, 14, 48. All right, ladies and gentlemen. So now we do the whole thing again. We say to ourselves, are there any negative numbers? Good news, there are no negative numbers. We're done. All right. So now we're done with the simplex matrix. We're ready to read our answer. So let's go back up to the steps. All right, next step. Read the answer using columns that only have one number and the rest being zeros. Any column with multiple numbers results in that variable being set equal to 0. And if you're sitting here saying, wow, I'm never going to remember this, I'm going to go through in the next video and explain why we're doing all of this, and that hopefully will help you remember the steps. So what it's saying here, remember, this is X, this is Y, this is Q, R, P, equal sign. Okay, so what it's saying, if a column has zeros in every position and only one value, we keep it. It doesn't have to be a 1. It could be a 7. It could be a -4. It doesn't matter. You keep it. So Y, again, has one number and the rest being zeros. Keep it. Here, this Q has lots of numbers. So we immediately set Q equal to 0 and we're done with that column. R, lots of numbers. Set equal to 0. Done. P, only, and P you always keep. Never get rid of it. And the equal sign, you always keep. Okay. Now, read your equations. What is this top row saying to me? So 0x's plus y plus 0p's equals 20. Now, do I really need all these zeros? No. So let's get rid of those. What we're really saying here is what? What we're really saying here is just y equals 20. The next one would be x equals 14. And the final row is p equals 48. And we're done. So now what we can say is we have a max of 48 at, whoops, x value of 14, y value of 20. And so you'll see in the next video, I'm going to go through this exact same problem, but we're going to talk about the theory and why this works. But you're going to see there's our max. We just found our solution without having to graph anything. And you might be saying, wow, graphing seems way easier. Well, wait till we get a little further. It's not going to be easier. But we can get through these problems without graphing. We can get through these problems in an algorithmic sort of way. All right, on to the next video.